Good morning everyone. Welcome to problem number 2. This is a question on the concept of electric circuits, how to solve problems in electric circuits and so on. And this question is taken from May 2006. This is TZ1. Okay, now let us solve with this. In the previous problem, when you look at it, this problem was really an excellent problem to show you what are the IV characteristics of an electric bulb or a filament and how do we determine this. Okay, so the current problem is also very similar to it. The similarity here is that, see, here also we had something like voltmeter was kept in series. So therefore, the most of the voltage was getting dropped over here, and as a result of it, the bulb did not glow. Okay, so this question is also very similar to this. Okay, that's why I particularly took up this particular question. Now, if you look at this, a particular filament lamp is rated at 12 volt and 6 milliamperes. So this is a 12 volt and 6 milliamperes. When you read the question itself, you would have understood what is it now. 12 volt and 6 milliamperes, which means I definitely need 12 volt for it to glow and 6 milliamperes of current should pass through. Okay, now next step. It just lights when the potential difference across the filament is 6 volt. Once again, okay, so it just lights, which means what? You require a minimum voltage of 6 volt to blow, okay, to blow it across. Just start. In the circuit, current setups, the student sets up an electric current to measure the IV characteristics. Okay, the circuit shown below, the student has connected the voltmeter ammeter into the circuit incorrectly, right? So why is it incorrect? Because you see, voltmeter is connected in series. How you should connect? You will always connect the voltmeter in parallel over here. Okay, any circuit, any element is there, then you should connect it in parallel. It is connected incorrectly. Okay, the battery has an EMF 12 volt, negligible internal resistance. The ammeter has negligible resistance, and the resistance of the voltmeter is 100 kilo. Very high resistance. Of course, I can't say anything about the voltmeter. Voltmeter definitely should have a high resistance, but unfortunately, this should have been connected here, but it was connected in series. The maximum resistance of the variable resistance 15 ohms. It's a potentiometer 15 ohms. There we had 100 ohms. Okay. Explain without doing any calculations whether there is a position of the slider S at which the lamp will be lit. Can the lamp get lighted on? Okay, because of this. Now let me assume without calculation. That's what he's asking. Don't do any calculation. We should do it. Now, see, since you have a very huge amount of potential resistance over here, most of the voltage that it comes over here will get dropped here. So as a result of it, the voltage that you require here to glow the bulb, which is 6 volt, will not be present, and hence the bulb will not glow. So this is the reason. Now, so what I should write? This is for 3 marks. So first mark will go for bulb will not glow for any position in S. So what do you mean by any position S? Which means I can take the slider, I can connect it here. If I connect it here, what will happen? The current which comes over here, it comes here and says this is an easy path, and then going like this would be a difficult path. Like this over here. If I connect it like this, it says okay, this is an easy path for me. Okay, because the resistance from this point to this point is 0. So all the current will go like this. No current will come here. Okay, let me assume I am not connecting it here. I will connect it here. When I connect it here, now it comes here, and then it says I am going to branch the current. Okay, and it says this is 50 ohms, this is 100 kilo ohms. Oh my god, 100 kilo ohm is too much. Okay, so therefore I will always travel through my nice road only. So what it will say is okay, I am going by the least resistance path. Still, most of the current will go here, and none of the current will come over here. Most. Okay, which means what? Suppose if the current coming here is something like around 10 milliamperes over here, I'm just giving an example. 10 milliamperes, 9.999 milliamperes will pass over here. Maybe 0.01 milliampere will pass over here. Is this sufficient? It's not sufficient. So therefore, nothing will come here, and hence most of the current will go like this over here. Okay, now I need to write the second point. What's the second point? Second point is that resistance. Now I already told you the story. Resistance of the alternate branch. What is the alternate branch? Alternate branch is nothing but the branch containing resistance of 15 ohms is an easy path, and hence all current will pass through. Okay, this is the second point that I can put. Then third current. Okay, therefore necessary voltage drop across the bulb, how much is it? 6 volt, will not be available. Okay, how do I know necessary voltage drop is not available? You can look at it from here. See, you are giving 12 volt over here. If you need 6 volt over here, it means 50% current should pass here, 50% should pass here. This is possible. For no position, 50% will pass here, right? Okay, so only 0.1% will pass here. Maybe it will pass over here, but almost all the current will only pass like this over here. So definitely, it will not give you the required amount of voltage. Okay, thus we have written 3 marks, 3 points. Estimate the maximum reading of the ammeter. You need to find out where is the ammeter kept here. Ammeter is kept over here. Okay. So as a result of it, now you see when current is flowing like this over here, it comes here. It doesn't go like this. Let me assume it doesn't go like this. Okay. So all the current goes only in the primary circuit. This is the secondary one. This is the primary. So which means what? The only resistance it sees here is 15 ohms. It appears this one is an open circuit. It says, hey, no, I'm not going to go like this. I'm going to go only in this direction, right? So therefore, your current I can be estimated as a 12 volt divided by 15 ohms, right? Because if you want, okay, so I can consider the parallel between these two. If I take the parallel between these two, it will be less than 15 ohms, right? And I want the total current over here. So which will now be 3 4s are 3 5s are 1 by 5 is 0.2 into 4 is 8. What is this now? 8 amperes. Is it 8 amperes? No, 0.8 amperes. 0.8 amperes. The current is 0.8 amperes. Let me write down how much marks? 2 marks. So therefore, I can write down the working and I can write this is equal to 0.8 amperes. The whole working what I have done here, you need to replicate and put it over here. Then complete the circuit diagram below showing the correct position of the voltmeter end and of the ammeter in order to determine the IV characteristics of the filament lamp. What is the circuit? I mean, nothing is given over here. What I will do is I'll copy from here. What all do I have? I have a resistance like this, and I will have a voltmeter, and I have an ammeter over here. So how do I put it across? What I will do is I will take the lamp like this. So this one here, this is my variable resistor, and from here I will connect a line like this over here, and then I'll put a slider here, and to this what I will do, I will put an ammeter here, and to this ammeter I will put the lamp here, and I will connect this circuit here, and across this lamp I'll put a voltmeter. That's it. Okay. So this circuit will definitely modify or will work properly. Maybe some of you might think, why ammeter here? I can put an ammeter here also. Okay, nothing wrong. You can put either here or here according to marking scheme. Okay, because why we think like this? Because voltmeter is not ideal, right? So the non-ideal one. So you can always put over here or you can put over here. But why I put over here is because the voltmeter resistance is seen to be 100 kilo ohm. Practically, if I compare to this resistance, it is very, very, very high. So as a result of it, I don't see any current entering through this one here. Okay, so and hence I put it over here. But if you still want to be sure, make sure that okay, you're doing it the right way, then ideally you can always put it over here. Okay, you can remove this one and you can put it over here. So with this, I think we have come to an end to this particular question. The next video we'll see the next question. Okay, thank you.